Okay. So you are from the University of Limerick.
Yes.
And this is your rocket. So could you introduce your team and the rocket?
Perfect. So we're ULAS HiPR, which is the University of Limerick Aeronautical Society high-powered rocketry. So this rocket is the third one that we've built. Its name is Airmed, which is an Irish goddess, and we've constructed this rocket primarily out of blue tube. It'll be going to 3 kilometers, and we're using an L645 for the motor, which is a COTS motor. We'll also be using COTS electronics, the egg timer quasar, and the CATS Vega.
Okay. So the blue tube is for the structural part and also the airframe. Why did you choose to use it?
Well, the thing I really like about blue tube is, despite shipping it from America, it is actually quite readily available, and you can get the airframe and the motor mount and couplers all from the same company, so they all work really well together, and it's really easy to machine, so you can cut it with a Dremel, bandsaws, chop saws, anything like that. So with the facilities we have available to us in the university, blue tube is an ideal choice for something like that, rather than using a phenolic or fiberglass or something that potentially you'd need more protection from when you were working with.
And blue tube is a type of plastic tube.
It's a resin impregnated cardboard, or a kind of a vulcanized cardboard. It's a form of phenolic, but kind of made in a different manufacturing process.
Okay. And for recovery, you are using the drogue and main chute. And how do you eject the parachute?
Yep, so the drogue will be in the center of the vehicle, and the main will be in the aft. So we're using black powder on either sides of this sled. We don't have the eBay in here right now, but the eBay sits in here, and our CanSat, which is our payload, will sit in here. So the black powder ejects on either side, and will eject the drogue and the main.
And what does the CanSat do? Does it do some measurement, experiment?
Yeah, so our CanSat has kind of 2 functions. We have a standard GPS altimeter that's just taking readings, and then we're also having a camera, and we're going to have an AI model running that when the camera takes pictures of the ground, it'll detect safe landing points, so it'll mask out areas that for potential future projects we could aim to land towards.